This video illustrates how to create a load duration curve within the FLUX model. I'm going to show how to do it in FLUX 3.05 first, and then FLUX 3.37, just in case you're using the older version of FLUX. So I'll open FLUX 3.05 to start this. So this is, as you can see, version 3.05. I'm going to open the session, the saved session, which I used before, and it works the same with either of the versions of the model. So I'm still working with the time period 2007 through 2012 for the sampling. The flow data is 1912 to 2012. Alright, so I can go through and I can do all these different use any one of these different keys, but for plotting, what we're interested right now is just to look at how to plot the load duration curve. So under the load, we can go to the duration curve, and I'm going to plot it, the log on the load axis, and leave the other axis linear. So you should get a plot similar to what we had for that you did when you did it by the method with Excel. Alright, so for the concentration, I'm going to use the 12.25 milligram per liter, which is 12,250 microgram per liter. And this then gives you the load duration curve. Here the units are in kilograms per year. You can change that to tons per year very easily. There are in the preferences menu for FLUX, you can change your output units to whatever you want to use. So anyway, what's shown here is the target curve, which is the black line, and the predicted load duration curve, which is the load estimate from the method 2. And of course this shows that the load estimate exceeds the target curve over the entire range. We can try a different method. Let's try method 6 just as a comparison, and note that we're working just with one strata right now. So we'll go back and look at multiple strata, but I think I'll do that with, well, I might do that with this method, with this version of the model, and then we'll look at the other version too. Okay, so the criteria is the same, 12,250 micrograms per liter. You can see for method 6 the curves switch. So method 6 is showing that the exceedances are predicted as exceedances above the target curve, or more up in the upper range of flows, and we're really not getting exceedances in lower flows. This is very much an effect of the fact that we're not using stratification. You'll see that when we stratify the data, even in method 2 will not have any exceeding load estimates that are above the target curve in the lower flow region. Let's go ahead and we'll look at some stratification, and the procedure will be exactly the same for version 3.37. There's just one difference that we have to go through for 3.37 version, and that has to do with we have to load in a regional criterion file, and I'll talk about that here in a few moments. So let's use these four strata for the flows. Okay, so we should be able to go ahead and do the if we do it for method 6, we'll do the load duration curve for method 6 because we still have that one selected. Again, the criterion is the same. Okay, so here again, it doesn't really change that much, the prediction by method 6, and that's because method 6 is a full regression type model that fits through the sample data very well, as in contrast to the method 2 and some of those lower level methods which make an assumption of using some sort of a flow weighted average over the entire strata. If you only have one strata, all the data are pulled together, the estimate of mean concentration is not going to be very good. If you break it up into multiple strata, you'll get a much better estimate. We'll see that when I look at method 2 here. Okay, let's do the plot again. Okay, so you see this is much more light. This is with the 4 strata. You see the highest strata, and then the red line is the third highest, blue is the second highest, and then the green is the lowest strata. And you can see that this looks a lot more like what we got for the method 6, and that's simply because our average concentration that we've got, flow weighted average, gets to be a better estimate of the relationship between TSS and flow when we break the flow up into a multiple strata. Okay, so this would be a low duration curve. It should be something similar to what you got for assignment 1. Okay, I'm going to exit out of here now that I've shown you how to create it with version 3.05. And I'm not going to save the settings because I don't want to keep the strata the way it is. And we'll go on and we'll look at version 3.37, which we need to do an additional step to make it work. So read in the save session. And one feature that version 3.05 does not have, if you look at 3.05 and look under calculate where you're calculating the loads, there's a line for TMDL low duration approach, but it's grayed out. It's not something you can select because it was under development. Now it's available. I've been told by the developer that this is still got some bugs, but it'll work for what we want to do, that is for plotting the low duration curve. If you want to plot a low duration curve with version 3.37, you need to first calculate with the TMDL approach. You notice that we can't use the low duration curve selection for plot right now, and that's because we haven't done that calculation. So you have to do this calculation first. Once you do that, then we'll see that for the plot we'll be able to do the duration curve. Alright, so here's we'll select the TMDL approach, and it asks for a drainage area. Drainage area is 114 square miles, which is, we can put this in square miles if we wish to. We put in the 114. Now it's asking here for the area units for the whole watershed that's that was monitored, which was 114 square miles. If your TMDL area is less than that, or maybe even if it's larger than that, the program is going to scale your results accordingly. So it asks for the actual TMDL watershed size. And here again we'll put that in as well, I was going to put it in, but it looks like it skipped it over on me. But it looks like I should have put in 114 square miles, but somehow my mouse jumped over things there. Alright, so what it asks for here is a target criteria, regional target criteria. The developer sent me this one here. I've added something to it, but it's just a text file or an ASCII file. And I'll prepare this, or I'll put it on the Moodle site for you to download it. It's a very short file, very small in size. But what it has in it are, for different regions, the limits set by the EPA, and in our case by the MPCA, for total nitrogen, phosphorus, other kinds of constituents, in our case TSS and turbidity. So I've added the TSS and turbidity limits in there. We open that. it then says, well, which constituent are we interested in? Well, we're interested in TSS. And I'll select that. Okay, so then we get this window. Says the criterion is not applicable yet. We need to choose the criterion as do not exceed. That is, it's our target limit. And in here, we can put a number in, or we can let the program select that number from the data. Okay. And what we need to do is to do the calculation of the TMDL. This information down here, I'm not going to use it in any way. If we had MS4s, if we were actually going to try to do the load allocation, we'd have to fill in some of this information down here. It doesn't really apply in our case. I think I'll actually change this watershed area because that's the thing that got skipped over. I'm not sure exactly why that happened. Well, I'll tell you why it happened, and my mouse was misbehaving. But here I'll actually hardwire this in. 295.3, that's the size of our TMDL watershed. So I could put in here permitted discharges and so forth like that, margin of safety. I could do all that, and it'll do all these calculations for you, which is really great. We're not going to do that at this time. We're going to first just be concerned about the homework assignment number 2, get the load duration curves created, and then you'll be set to go. Here we have to do the TMDL calculation because then it'll create the data for preparing the load duration curve. So I press, oh yeah, it says the criteria value is invalid. I'm going to put in here 12,250. I'm not sure why that happened that time. I've been through this once before and it worked the first time. Might have been that problem with the mouse. But anyway, okay, so that's the criterion that we're going to go by. Do the calculation. It takes a moment, and what it'll do is then tell me when it's ready by bringing up a table with data in it. We'll just say yes to this. Doesn't hurt anything if we do, and I'll just call it TSS. So here's our table, and this then has the information about what the probabilities of exceedance of different loads. It goes in and shows in detail the target concentration, the MS4, that is the WLA allocation, the total WLA, the margin of safety, and so forth. So we're not going to use that, as I already mentioned. We could go back to our main menu, or I could just do the plots for the load duration curve directly here. So here's our load duration curve, and if I say OK, it gives me that same warning about samples being less than 0.2% that we saw with version 3.05, and that's OK. So here's our plot, allowable load and the predicted load. This is with, well, it says it's method 2, and yeah, that's what we got previously with version 3.05. The method 2 was uniformly above the target curve over the entire flow range. Again, we could decorate the axes in any way we want, but this is generally how we'll want it to look anyhow. Now if we want to go back and try a different method, such as method 6, we have to go through the same steps, or at least that's how I've done it. And what we do is we come back to the main menu, we choose method 6, and we have to again do the load duration calculation all over again. Okay, here we have the same criterion in there, and I'll say calculate TMDL again. Alright, and then I can do the plot for method 6. Okay, this is what we got before with version 3.05, where the load estimate curve is below the, or much of it is below the target curve. And of course, if we add more stratifications, let's say 2, 3, or 4, we get a better result. Actually, with method 6, it doesn't change very much, but with method 2, it certainly changed quite a lot. So again, you can download these figures and put them into your assignment report. There may be some shortcuts that could be made here to create these two curves, or to create the load duration curve. I haven't tried this out enough to see what those shortcuts might be. It certainly was much easier, or much more straightforward with version 3.05, but version 3.37 is going to, and later versions are certainly going to offer a great deal by the fact that you can get those load allocations automatically or done for you through the FLUX model. So that'll be a big help. Further testing that can be made here will maybe identify some shortcuts that could be made, but I haven't identified those up to this point. Okay, the name of the file that we're going to use, that I'm going to put online, is region 7 targets _ new. If we look at that file, we can I'll open the file and show you what it is. This is what the author, the developer of the model, sent me. It had everything except for this last line on it, number 99. I just call it Eco 99, which we'll say is the North Shore where Poplar River is. I just put some numbers in here for the total nitrogen, which would be like the nitrate concentration in milligrams per liter. Total phosphorus, which 0.04 microgram per liter. The NTU is 10, and then the TSS can either be obtained by putting a formula in here that relates TSS to NTU, or you can just put the number in there. I put in 12.25 because my regression of NTU versus TSS gave me a slope of 12.25, and at 1.225, and at 10 NTUs, that gives me a concentration-free TSS of 12.25. Okay, so I'm going to load that file up onto the Moodle site, and you'll be able to download it and then work with it. It turns out that version 3.35, which is the one that's actually loaded on the public computers, basically has the same keys and so forth that 3.37 has. So hopefully it'll have, I haven't tested this out on 3.35, but I imagine it'll work just fine. It probably is not exactly the same as 3.37. So I'll put that on the website, and then you'll be able to go ahead and use it. And please let me know if you have any troubles with it.